Now that we've got a basic view of what circles are composed of in terms of arcs and inscribed angles and diameters and central angles, we're actually going to get into a little more nitty gritty here with what's known as arc length and area of sectors. So, what the arc length is, it's the distance between endpoints along an arc measured in linear units. Since it's a portion of the circle, its length is a fraction of the circumference. So that's going to come into play here when we try to figure out the actual length of an arc. So in terms of the word definition of arc length, it's the ratio of the length of an arc L to the circumference of the circle and is equal to the ratio of the degree measure of the arc to 360 degrees. So notice over here we have our circle here, we have radius r, central angle x, and arc length of L. So what exactly does this proportion look like? Well, it says the ratio of the arc length L to the circumference of a circle. Now, there are two different formulas that we could use to figure out circle depending on what we are given. Now, it could be found on the New York State reference sheet, but circumference is equal to 2 times pi times the radius, or it is equal to pi times the diameter. So again, twice the radius is going to be the diameter. So we could use either one of those formulas depending on what we're given. If we're given the radius, we're going to use 2 pi r. If we're given the diameter, we'll use pi d. But for intents and purposes of this one, circumference, we will use the formula 2 times pi times the radius, and is equal to the ratio of the degree of the arc. In this case, it's going to be x over 360 degrees. So there's the proportion. We're going to be using this proportion in order to figure out either our central angle or the length of our arc L. The other way that we could have used it, instead of 2 pi r, the optional would have been pi d, pi times the diameter. So depending on what we're given, we're either going to have 2 pi r in the denominator of our first fraction or pi d. So we have to find the length of arc zy in these circles and round to the nearest hundredth. So here we're given radius r, central angle 75, and we need to find the length of our arc here. So again, length of arc over 2 pi r is equal to our central angle over 360. So we're going to fill in the missing pieces. So we don't know what L is, so we're going to leave it as that. So 2 pi times my radius, which is 4, gives me my central angle of 75 over 360. So what we can do is we can cross multiply here. So when we cross multiply, we end up with 360L is equal to, and what I'm going to do is I'm just going to multiply the numbers that we have. So 2 times 4 times 75 gives me 600. So we have 600 and then pi. So what I want to do is I want to solve for L, so I'm going to divide by 360. So those are going to cross off. They're going to cancel out. So I'm left with L equals, and then I'm going to do my 600 pi, and then the pi symbol is in yellow above the little caret symbol on the right-hand side. So it's second caret gives me the pi symbol. And then we divide by 360. And I get an approximate value of 5.2359, round to the nearest hundredth, so 5.24. Now for letter B, we're going to be doing the same thing. We need to find the length of arc zy, so there's our length. Now, we know we can either continue on with 2 pi r or pi d, so we're given a diameter of 10 centimeters. So our proportion is going to remain the same. Length over, in this case, we have our diameter, so pi d, is equal to our central angle over 360. So we don't know what the length is, but we do know we have pi times 10, so we have 10 pi on the bottom here. Our central angle for zy is 130 degrees over 360. So we cross multiply. 130 times 10 gives me 1300 pi is equal to 360 times the length of my arc. So we divide by 360. So again, we have 1300 pi divided by 360. Gives us an approximate value when we round to the nearest hundred, 11.34. So we have 11.34 is our length of our arc. So that's finding length of arc. Now notice we've been using the number pi here. So pi, whenever we tend to use pi in circles, we call it a radian measure. Now what a radian is, pi radians is really equal to 180 degrees. And in order to convert degrees to radians, we simply multiply by pi over 180. So if I wanted to convert 120 degrees to radians, I would just take my degree measure, in this case it's 120, and multiply times pi over 180. So we multiply straight across and we end up with 120 pi over 180. And what I want to do is I just want to reduce the numerical fractions. So I'm going to ignore the pi for now. I'm just going to divide 120 by 180 to get the decimal 0.666666. And I want to change it back into a fraction. So math, enter, enter on our graphing calculator. Gives me 2/3. So that is equal to 2 pi over 3. So there is my radian measure of 120 degrees. It's really 2 pi over 3 in regards to the radian measure. Now, angle B here, what is the measure of the angle in radians? Well, we're told that we have a section here, 2 pi, radius of 10, so we can use our previously learned proportion in order to figure it out. So we are told our length of arc is 2 pi over 2 pi times 10 is equal to our central angle over 360. So we can cross multiply, so we got 720 pi is equal to, and again we don't know what our angle is, so there's our unknown, so we have 20 pi times our angle. So I'm going to divide by 20 pi. And we get a central angle of, and again I just want to divide our numbers. So 720 divided by 20 gives me 36. So my central angle is 36 degrees. Now it says to give the measure of the angle in terms of radians. So what I have to do now is I have to multiply 36 times pi over 180. And I end up with 36 pi over 180. And again, we just divide our numbers. 36 divided by 180. I'm going to get 0.2. So math, enter, enter, gives me 1 over 5. So we end up with 1 pi, or just pi, over 5. So that is the measure of angle B in terms of radians. So we use our formula that we learned previously to figure out that the central angle is 36 degrees, and then we multiply it times pi over 180 to get the radian measure of the central angle. Now the area of a circle is pi r squared. And what a sector is just a portion of that circle enclosed by 2 radii. So before we found the length of the arc, now what we're going to do is we're going to be finding the area of that section created by the central angle in that arc. So again, we're going to be using a proportion where the area of the sector is proportional to part of the central angle is of 36 to 360 degrees. So basically, it's the area of the sector divided by the area of the circle is equal to our central angle over 360. So that proportion is what we're going to be using. So very similar to the length of the arc only we're going to be doing the area of the sector instead. So we have to find the area of the sector here in the right. So again, area of the sector, over the area of the circle is equal to our central angle over 360. Now we don't know what the area of our sector is, so that's our unknown x. The area of the circle is pi times my radius squared, and the radius in this case is 2 squared is equal to my central angle, 90 over 360. So again, just like before, we cross multiply, so we end up with 360x equals, and then 90 times 2 squared is 360, so 360 pi divide by 360. Then we get x equals pi, which is really 3.14 inches squared. And again, you can always check the calculator. 360 pi divided by 360. 3.1415. So the area of the circle is 3.14, rounded to the nearest hundredth. Now let's say we have a sector of, let's say we want to find the area of a sector of a circle if the radius is 10 centimeters and the central angle is 72. So first thing we would like to do is we should probably draw a picture so that way there we kind of have an idea. So here we have a circle. We have a radius of 10 and a central angle of 72. So we have 10 centimeters and 72 degrees. So we need to find the area of this circle. So the area of the circle, the area of the sector, which is our unknown x, over the area of a circle, which is pi times radius squared, is equal to my central angle over 360. So we plug in numbers that we have, so we don't know what our area of the sector is. However, we do know our radius is 10, so pi times 10 squared is equal to our central angle, 72 over 360. So we're going to cross multiply our numbers here. So 300x times 360 gives me 360x equals, and then 72 times 10 squared gives me 7200 pi. Now we're going to divide by 360. So we get x equals 20 pi, which has an approximate value of 62.83 centimeters squared. And we can keep doing this for the different circles, and C and D are very similar in that sense, same with E. So number 1 here on the extra practice problems is a little bit different. What we have here is an equilateral triangle ABC with edge lengths of 20 centimeters. D, E, and F are midpoints of the sides. Vertices are the centers of the circles creating the arcs shown. Find the following, and we have a whole bunch of different things. So basically what we have is we have an equilateral triangle here. The endpoints are center points of the circle that if I were to keep going around, I would have a circle around point A. And the arc here that we have is arc DE. Same with B. I actually have a circle going all the way around B with arc EF shown, and same with C. This C is the center point of the circle, where DF is part of the arc of circle C. We need to find the area of the sector with center A. So what we have to do is we have to use the information we're given. We are told we have an equilateral triangle with side lengths of 20, and D, E, and F are the midpoints. So A to C is 20. So if D is the middle, that means A to D is going to be 10. D to C is going to be 10. So there's my length of 20. A to D is 10. D to C is 10. There's my 20 from A to C. CF is going to be 10. FB is going to be 10. EB is going to be 10. AE is going to be 10. So what we can do is, because we know this is the center, we know the radius of each circle is going to be 10. So we have radius of 10 for our circle. The other thing that we have for an equilateral triangles, all lengths and angles are the same. So we know a triangle is comprised of 180 degrees. So we divide 180 by our 3 points, which means each angle created is a 60-degree angle. So angle A is going to be 60, angle C is going to be 60, and angle B is going to be 60. Hence equilateral triangle. Sides are the same, angles are the same. So we have central angle of 60 degrees, and we can actually use proportion, the area of a we can use the area of the sector proportion equation to figure out the area of the sector with center A. So the area of our sector is our unknown, so x, over the area of a circle, pi times radius squared, so 10 squared, is equal to my central angle, 60 over 360. So we cross multiply. So 360 times x gives me 360x. 60 times 10 squared is going to be 60 times 100, so 6,000 pi. And then we divide by 360. And we get x is approximately, so 6,000 pi divided by 360 gives me an area of approximately, to the nearest 100, 52.36. In this case, centimeters squared. Now we have to figure out the area of the triangle itself. So what we have is an equilateral triangle. We could essentially figure out the height of the triangle using Pythagorean theorem or unknown, then we double it together. But we also have trig at our disposal. So remember, the area of a triangle is equal to 1/2 AB sine C. So as long as I know two sides and have the angle of the third, we can figure out the area of the triangle using trig function 1/2 AB sine C. Now the one thing when we're using trig, remember we like to be in degree mode, so as long as we check our mode, notice I'm still in radian, I'm going to change it to degree. So I'll just hit enter and quit. So now we know the two sides. Side A is going to be the full length here, so side A is going to be 20. Side B is across from side B, so the whole length is 20, so we're going to use that. So 1/2 of 20 times 20 times the sine of angle C. Angle C is 60 degrees. So all I have to do is plug this all in. So we have 1/2 times 20 times 20 times the sine of 60. And we get 173.21 if we're rounding to the nearest hundred. So 173.21 centimeters squared. So now what we want to do is we actually need to find the area of the shaded region. So the area in the shaded region is in the middle of it. Now we found the area of sector A to be 52.36. So if I know the whole area of the triangle, and all I want to do is find the middle section, I have to get rid of the parts that are actually part of the circles. Now, what we already know is that the area of each sector is going to be 52.36 because it's all going to be the same formula. So notice we have the same numbers all around for the different circle sectors. Well, if the sector A is 52.36, that means the area of sector B is also going to be 52.36. And sector C area is 52.36 as well. So all I have to do is subtract those areas from the area of the entire triangle. So we really have 173.21 minus 3 times 52.36. And that's going to give me the area of the shaded region. So 173.21 minus 3 times 52.36. And it gives me an area of 16.13 centimeters squared. So that one was not as difficult as it may have appeared. So again, equilateral triangle, meaning the circles are also going to be the same size due to the same numbers. So the area of each sector ends up being 52.36, and we subtract it from 173.21, and leaving me with 16.13 centimeters. Now we want to find the perimeter of the shaded region. Now perimeter is the length of everything. So I could say the perimeter of our equilateral triangle would be 60 because it's 20 plus 20 plus 20. So I actually need to figure out the length of the arcs. And again, once I know the length of one arc, they're all going to be the same because the numbers are the same for everything. Central angles of 60, sides of 10. So all I have to really do is figure out the length of one arc and then multiply it times 3. So again, it is a proportion. So the length of the arc is equal to the overall circumference of the circle, so 2 pi r, and that is equal to the central angle over 360. So we don't know what the length is, but we do know the radius of each circle is 10. And the angle, the central angle of our circle is 60 degrees over 360. So we're going to cross multiply. So 2 times 10 is 20, times 60 is going to give me 1200. Pi is equal to 360 L. And we're going to divide by 360. And we get L equals, and then we divide 1200 by 360, leaving me with 3.33. Pi. So I multiply 3.33 times pi. So I have an approximate length of arc being 10.46. So now that we know the length of one arc is 10.46, that means the length of 3 arcs is, the length of each arc is going to be 10.46 as well. So there were 3 arcs, so all I have to do now is I have to multiply 10.46 times 3. And that's going to equal my perimeter. So 10.46 times 3 gives me an approximate perimeter of 31.38 centimeters is equal to my perimeter. So again, we can use these proportions to figure out lengths of arc. The length of arc is equal the length of the arc divided by the circumference of a circle, 2 pi r, is equal to our central angle divided by 36. We can also find the area of a sector by setting up the proportion. Area of the sector over area of the circle is equal to our central angle over 360.